And I would like to introduce Dr. Jim Green. He is our chief scientist at NASA headquarters for NASA. And he will be giving a talk on the Cis-Lunar exploration in life sciences. Dr. Green. Thank you.
Thank you very much. Well, it's a great pleasure to be here to talk about cis-lunar exploration, and in particular in the area of life science and physical science. What I'd be remiss if I didn't start out with talking a little bit about the 50th anniversary. And this isn't my clicker. This must be the clicker. Yes, got the right clicker. Sorry about that. So indeed, 50 years ago is the anniversary of Apollo 11. And you may not realize this, but NASA doesn't do Star Trek. You know, it's not go where no humans have gone before. We do a lot of work prior to sending humans to places like the moon and then on to Mars. And so indeed, more than 22 missions were launched and executed at the moon prior to Apollo 11, gathered all kinds of information necessary to understand the environment and to be able to reduce the risk for the astronauts, then to be able to land and deploy instruments, be able to collect lunar material and bring it back. And indeed, for the Apollo program, 6 major missions, 11, 12, 14, 15, 16, and 17, at mid to near equatorial regions on the moon, all of course on the near side, did an enormous amount of work. And they brought back approximately 850 pounds worth of lunar material. This is not only rocky material, but regolith and even cores. And what's happened over time is we've taken a fraction of that and be able to release it to the world community of scientists to be able to do the analysis, where we've also stored a significant amount of that material. And in fact, one of the cores that were done by Harrison Schmitt on Apollo 17 was recently opened for, so for the very first time. And this is really important to do, because as our laboratory equipment gets to be really significant and developed over time, to be able to do high resolution imaging in mineralogy and tease out isotopic ratios, et cetera, within the material, we need to keep as much of it as necessary to be pristine to then be used in these new analysis techniques. Now, in these 50 years, what I would say, what we learned from Apollo, and these are the top things, is that the moon is old. It's 4.6 billion years old. Here on Earth, some of the oldest rocks that we can get a hold of, they're in Australia and some are in Greenland, small regions, date back to perhaps 3.8 billion years. So by going to the moon and obtaining pristine material from the time the moon and Earth system were actually created, really enables us to start an understanding of the age of the solar system and what happened in terms of the bombardment history of the solar system since then. Because indeed, the moon doesn't have an atmosphere. And although the tidal forces between the Earth and the moon enable the moon, from that heat being dissipated in our ocean, to move away from the Earth about 1.5 inches a year, also helps us understand where the moon must have formed in that original time of creation, very close to the Earth. In fact, the top hypothesis based on the lunar material record is that the Earth and the moon are essentially the same, made up of the same material, so that they were created pretty much in the same area of the solar system. And that's through the isotopic analysis of the material we brought back. The concept then that the moon and the Earth were created in a violent event occurred at 4.5 or so billion years ago. The proto-Earth and another object we call Theia, which is about the size of Mars, impacted the proto-Earth The end result was the Earth-Moon system, for which then the moon is only about 3 Earth radii away from the Earth, and then will consistently move away from the Earth over time. And that means the moon formed in a molten way. And this created a molten ocean of magma across its surface. And that was teased out by the lunar material we brought back and the anorthosite that they found in each and every one of the examples of lunar material brought back from Apollo. So that means then, without a lunar atmosphere, at least of any significance, the bombardment history of the moon is the bombardment history of the inner solar system. It hasn't eroded over time, and that the major geological processes that are going on are really due to the impact cratering. One of the spectacular things that happened based on aging of the rocks that we brought back is that another period of bombardment occurred well after the Earth and Moon formed. And this is approximately 800 million years after the Earth-Moon system were formed. This is called the late heavy bombardment. And this bombardment is really significant. In fact, when we look at the moon today, we see the darker areas. These are mare. They were called mare early on, seas, if you will. But what they are magma that has filled in large impact craters that we call basins. They're so large that a significant amount of crustal magma and mantle material came up and filled in these locations. They're dark because the composition has much more metals associated with it. And so you see a great contrast between that and indeed the rest of the crust of the moon. What's important about that is indeed that changes the gravitational mapping of the moon, such that mass concentrations, these magma producing mass concentrations, actually shifted the moon such that we then have the large masses, these mass cons, these mare, pointing to the Earth that are tidally locked, but also it shifted the pole. And that's important, and I'll explain a little bit more about what's happened in that area as we discuss what's going on in the polar caps of the moon. Now we have, since the Apollos, a whole series of missions that have really teased out much more information about the moon from a global perspective. And here is a great composite from the Lunar Reconnaissance Orbiter of a month on the moon. You know, the public likes to think that maybe it's Pink Floyd that did this to everyone, that the far side of the moon is the dark side of the moon, but in reality, you know, the far side of the moon goes through the thermal extremes as indeed you see here. And in the polar cap, in the southern polar cap in particular, as you see here, we have really some important places where we have sunlight over longer periods of time than the 2-week normal period if you were at the equator. And we have locations that never receive sunlight, where we have permanently shadowed craters. And so there are thermal cycling of the moon, which this is a wrap of 1 day in terms of the temperature range of the moon that then slides over a month period. But the real extremes are in indeed the polar cap region. So as you see on the left, this is a great example of illumination, regions that are illuminated over a certain percentage of time. And then as you can see, there are quite a few deep craters that are permanently shadowed. And in these permanently shadowed craters, on the right side, we see the temperature variation, and it is extensive. In fact, in these permanently shadowed regions, they are so cold, they're actually colder than the surface of Pluto, you know, which is about 44 or so, or 42 astronomical units away at times. So the thermal cycling can be quite significant on the moon, and perhaps that is an important element of any experiments in life science and physical sciences that you may be thinking about. What's in these permanently shadowed craters, and this has been teased out by a variety of instruments that look at impacts from cosmic rays and then the resulting material that comes back, neutron albedo in particular, is that we can map where a significant amount of water is residing. And in fact, the two major ones that are labeled here, Shackleton and Cabeus, see a large concentration. Now, it turns out, instead of looking at the concentration of water in such like an Arctic circle, we see much more of an oval shape. And this oval shape of water across the south pole of the moon is matched in the northern hemisphere. And this led us to the understanding that sometime in the lunar evolution that the pole moved. And in fact, it's now believed that the original south pole of the moon was at Cabeus. And then 800 million years after the creation of the Earth-Moon system and this heavy bombardment was occurring, and the mass cons were being created, the Mare were being created, the pole cocked, and now it's right at the rim of Shackleton. That's where the South Pole is. Now this means that then the water distribution, as you see here in blue, scientifically is going to be very important to be able to tease out what's happened in terms of its evolution. Early on, the water distribution would be primarily in the Cabeus area, dominated by comets and asteroids. Actually, asteroids have a significant amount of water in them, and so impacts that then destroy the impactor and liberate material and water then gets trapped in these permanently shadowed regions, then are representative of the water from the object itself. So indeed, scientists that want to go to the permanently shadowed regions, and one of the first things they're going to do is want to core these. They're going to want to core and get the evolutionary record of what's happened in these areas. As I mentioned, we think it's going to be quite different from the Cabeus area versus the Shackleton area. The reason why is during the time of the filling of the very large basins created by the late heavy bombardment and the magma coming up in it, the outgassing that we predict was quite extensive. So the outgassing would have CO, CO2, in addition to H2O, and formed a thin atmosphere at the moon. Some estimates are that it might be as much as 10 millibars. And we don't know exactly for how long, but this is also during the time that the moon actually had a very extensive magnetic field. So that would protect it for as long as it could. And indeed, what happened is that it must have snowed out. It must have, the atmosphere must have collapsed. And so in the polar regions, and so in the Shackleton area, it might be much more of the CO, CO2 in addition to water. So the cores in various locations along this stretch will be very important. Now, of course, we're only seeing indications of the H2O, of the water, or hydroxyl, all right, in these regions. And that current estimate tells us that there's between 100 to 200 million ton of water in the northern and southern hemisphere, with the southern hemisphere having the largest concentration of it. But as I mentioned, there might be other sources of oxygen through CO and CO2 that's also deposited in these regions. And this is becoming really an exciting area for discovery for scientists. Now, what's happening, and one of the ways we obviously, as I mentioned earlier, from cosmic ray impacts and these over the moon, there is a radiation of albedo that occurs. So the galactic cosmic rays will penetrate on the order of a meter or so. You end up with secondaries that then are liberated. These secondaries are not only neutrons, protons, photons, electrons, or even positrons. And indeed, we've made measurements of this, and we understand what that flux is. Also, experiments on the moon that are worried about the radiation must recognize that the moon is actually covering up half the sky. If you're on the surface of the moon, you actually have already half the cosmic ray input. And then you have the secondaries, which amount to about 12% of the total radiation that you then have to deal with. As we've learned about the moon and the vast amount of water that's trapped in the permanently shadowed regions, it comes along at a great time that we end up with Space Policy Directive 1. And let me read you a couple sections of that. This administration wants indeed us to move forward and lead an innovative and a sustainable program of exploration with commercial and international partners to enable human exploration across the solar system. Now, the first start of this, of course, is that we want to return humans to the moon for long-term exploration and utilization, followed by human missions to Mars. So we also want to learn how we will live and work on a planetary surface using the moon first and then going on to Mars. The other challenge we receive from the administration is, of course, that we want the first woman and the next man on the surface of the moon in 2024. Now, we've been developing a variety of things getting ready for exploration beyond low Earth orbit for many, many years. And so we are positioning ourselves to be able to indeed meet that 2024 challenge. And so this is really an exciting time for us, and I want to talk about what these environments are like and how that program is going to lay out over the next 10 years or so. But what I want you to keep remembering is the sustainable part. This is not the Apollo program. This is not being able to land on the surface, deploy some instrument, obtain some lunar material, and return in a very short duration way, only staying on the moon a day or so or less. We want to change that entire paradigm. We want to look for ways where we create an infrastructure that we leverage and use. And we want to also be able to look at ways that we will be able to live and work on that planetary surface, not for days or maybe even weeks, but perhaps for months. So this is quite a challenging opportunity for us. To start, as that Space Directive 1 has indicated, we will work with our commercial partners. Last year, we announced that there were 9 major commercial partners, and just yesterday, or perhaps the day before, we announced several others, which included Blue Origin and SpaceX. But didn't have a time to change my slides. So here are the major 9 that we're working with, and this is through the Commercial Lunar Payload Services. These are organizations that are moving forward with their concepts of being able to land on the moon or orbit the moon and provide us opportunities for NASA experiments and NASA-funded researchers to be able to propose experiments and be able to put on these systems that then will land on the surface of the moon. Now, from the experience of the science that we currently have, we want to be able to take advantage of the commercial environment for which the first 2 planned launches, let me go back one, sorry, is Astrobotic and Intuitive Machines in July of 2021. And they will take a variety of NASA-funded investigations to the moon at locations that they're able to reach. And of course, that means the whole moon is going, we want to be able to explore various aspects of it, and the whole moon we want to be able to have access to. And in addition to studying more directly with landings on the South Pole. And so our first set of South Pole missions will indeed be designed to feed forward in human exploration, provide information necessary for us to be able to plan our human exploration efforts next. What we've been developing over the last many years, of course, is the Space Launch System and the Orion capsule. This is a significant rocket with tremendous capability. It's designed to go to Mars and therefore allow us to take humans to the moon in a major way. This system then is a major part of the Artemis program. So Artemis Phase 1, in addition to our using and leveraging the commercial environment, will be to use the SLS and the Orion capsule in a series of missions. The first mission, Artemis 1, is being planned for the end of next year. That first launch will be uncrewed, do sort of like an Apollo 8 mission to the moon, where we'll launch this uncrewed Orion capsule, orbit the moon very quickly, return, and be able then to ring out the system. Then the next planned mission is also a rendezvous mission with the moon, where we'll orbit that and return, but that will be crewed after we understand aspects of how Artemis 1 worked, with the eventual then EELVs bringing up much of an infrastructure that will be developed over time called the Gateway. Now the Gateway then will end up with some small habitation capability, but it be designed to mate and have the not only descent system, but the ascent system that we then will deploy. Now, this gateway is absolutely essential for the 2024 mission. So as we put it together, it will end up in a orbit, a highly elliptical orbit around the moon, with the Perloon in the northern hemisphere and the Apollon in the southern hemisphere, with a 6-day orbit. Now from that position in the southern hemisphere, we're able to see such a significant part of the moon that we then can also open up investigations for commercial activities and other agencies even to be able to land on the far side of the moon. Now the far side of the moon has a really unique structure, has a lot of the highlands, but it also has some of the lowest areas on the moon, such as the area called the South Pole Aitken Basin in the southern hemisphere, where a huge impact blew away most of the crust. And so you have the upper crust, or the lower crust rather, or the upper mantle material laying right on the surface. We now understand that what hit that was a protoplanet, which had differentiated, and with a significant core that was probably on the order of 150 to 200 kilometers in size, that's buried in the center of the South Pole Aitken Basin. But the material that it brought to the moon has been thrown out all over the edges of this large cratered areas, and it has a lot of platinum group metals. So there's a lot of opportunities to do mining in this particular area too. What we'll see then is the end of phase 1, once the gateway has come together. The Artemis 3 mission will then dock. 2 astronauts then will egress into the ascent and descent stage, go down to the moon, perform a variety of experiments, pick up some samples. You know, I've always said, they better be picking up samples or they ought to just stay there, right, until they do. We need those samples back. It's from a very important, unique area of the moon, and then return in that way. And now this enables us, with the gateway capability, to be able to perform in a limited way a variety of life science and physical science experiments. Phase 2, this is our notional idea of what will happen after 2024, taking us to the end of that decade, will indeed include 4 more missions, Artemis missions to the moon, then also performing a lot more experiments in the area of sustainability. This indeed is where we'll have to perform experiments in terms of plant growth, in terms of understanding much more about the radiation environment and the mitigation strategies that we would have to employ. So the phase 2 part is what we're pointing to be able to do some initial research in these next 5 years, and then more implementation as we move forward. Some of the ideas in terms of, and this is only one of many, comes from the Colorado School of Mines. I thought I'd mention that and show that since we're right here in the Denver area. This is a way we're going to be able to perhaps extract the water out of a permanently shadowed crater. This is a dome that's set up over a water resource, reflectors that will take sunlight, shine it into the dome, and then use a reverse process. The sublimation will occur. We'll have cold traps sitting on the side, and the water will move into the cold traps, and then we'll be able to extract the water in these large tanks. Now, in addition to that, this also works for us in terms of having the total solar spectrum available to us. We can either use it all or take parts of it, and that will figure into a variety of experiments in the life science and physical science areas too. So once again, the Artemis 2 phase in that 10 years is going to touch on many of these aspects, and it really is going to be up to us in many ways to be able to do a lot of research, define better what sustainability is, identify those gaps, being able to find the funding associated with doing the research that will enable us to go into each of these areas more, as much as we can, or more so than some. Science and exploration is really a critical one. This will be from planetary science, astrophysics groups have plans of putting telescopes on that far side of the moon, away from interference from Earth. Also going into experiments living off the land. This is where we'll have opportunities to grow plants in this environment. Now, this environment has many similarities to Mars, but not a complete one-to-one analog. But indeed, research in this area will be absolutely significant and feed forward to us. The concept of being able to then extract the water as a resource, and as I mentioned, there's other resources that like the platinum group metals, and then be able to take the water, separate it, using it as an example of rocket fuel. So the cryogen part of being able to maintain these sources are going to be important, and a lot of research needs to be done in that area. Of course, you want to be able to drink the water, and you want to be able to tease out the oxygen. And whether it's from the H2O or, as I mentioned earlier, there might be a significant resource of carbon monoxide, carbon dioxide. So there is additional oxygen opportunities for us. But indeed, we'll need that as developing an atmosphere. And then, of course, being able to use these three sources: fuel, atmosphere, and consumable water will be important, and an element of the fuel depot. And as I said, part of this may be we work a little bit into the manufacturing and mining area, which will be necessary to extract those resources. Now, overall, here's a sort of a notional idea of the biological sciences and the physical sciences that will be discussed more by others. As we know, we do what we at Earth, and of course in ISS, as we move now towards the gateway, we have opportunities to begin some basic experiments in crop production, where you're out in what we'd call deep space, be an environment that's different than space station. We want to be able to validate what we can do on our way to Mars. Then there's the lunar surface, where we want to be able to accommodate a different particle environment that's not only half cosmic rays, but you also have the secondary albedo radiation that's there. And on Mars, even though the atmosphere is thin, the cosmic ray dose is very similar to what we see here on the moon. We'll only get about half of it. And then, of course, there's the microbiome research that we want to be able to do both on the gateway lunar surface, but also pointing towards Mars. The partial gravity, here we have an opportunity to go from the microgravity at station, 1/3 gravity in the gateway, but then down on the lunar surface, which is 1/6, and then 3/8 as we then perform experiments that'll hopefully be viable on feed forward to Mars. In the physical sciences area, the lunar surface, of course, is important for us to study dust mitigation activity. So we know a significant amount about the lunar dust. Mars dust, which is different in composition and consistency, still is something we need to work on and mitigate. We have the cryogenetic aspect of the research, as I mentioned earlier, but we also are going to be doing research in flammability, but also understanding extraction of resources from the regolith. In the area of physical sciences, we have a variety of materials. We also have potentials for quantum communication. There's just a number of experiments that then indeed could be performed in this next decade. So we must be creative about understanding what sustainability is all about. We must be able to define, based on research that we're funding now, what those gaps are that would significantly enable humans to live and work on a planetary surface, moon first, and then Mars. So indeed, this next decade will be extremely important to us. And I'm delighted to be part of the decadal discussion that will happen next. Thank you very much. Do I have time for a few questions? Two questions. All right, if not, there we go, and the mic's back there. That's a good question. So an aspect of the SLS does leverage the shuttle engines, okay? So there is a feed-forward heritage that's there. In terms of funding the Artemis program, NASA, of course, only gets funding from Congress 1 year at a time. But with the administration, we encompass a projection of 5 years. This enables us to have in the horizon 2024, all right? So that means not only Artemis 1, 2, but 3 are being proposed through the budget we've provided to Congress, the president's budget that we'll be delivering in February. And then, of course, we've already given Congress a supplement for the fiscal year 2020 to be able to get started on that overall budget profile. So the concept is Congress has to be able to respond positively to provide us the funding that will enable us to then make that 2024 deadline a reality. All right, thank you very much.
All right, so now what we're going to do is the Decadal Survey status and discussion. Now, this is going to be, and I'd like to bring to the stage Dr. Sandra Graham of the National Academy, Dr. Rob Ferl, Dr. Dava Newman, and again, Dr. Jim Green. Now, this is going to be an interactive. There will be a presentation. However, you'll notice that there are white pieces of paper on your chairs. That's for you to go ahead and write questions. There'll be someone who comes by to take those questions, and also you can use the microphones to ask your questions as well. There'll also be a poll that's going to be taken to look at what this community feels is the important areas that the Decadal committee needs to consider. So please, this is your opportunity to ask questions, provide comments, and information back, and for the poll. So please take advantage of this.
Dr. Clicker.
Thank you, Kevin, and thanks to ASGSR for basically letting us be a part of today's activities. boy, as scientists, it's just really important to realize that there are times, they may be rare times, but there are times when we do have control over our future, where we do have control over the input to policymakers and to administrators that do decide eventually what we get to propose to. And the Decadal Survey and the process that the National Academies puts together to inform the government, to inform the policymakers, is such a huge part of the science that we eventually get to do, that it's really important that we grab a hold of the opportunity to have input to that process, especially for the younger people that are here. Again, when we come up through graduate school, we don't really realize that eventually we do have some control, some input, some deciding power into the kind of science we get to do. It just so happens that in the space business, there's an exquisitely well-developed and nicely controlled, nicely put together process that allows science to inform policy and for administrators to draw upon that expertise when they decide exactly what to do, for example, on the moon. So what we want to do today is talk to you about the upcoming decadal process. And to do that, David Newman and I, we co-chair the Committee on Biological and Physical Sciences in Space for the National Academies. This is a standing committee that works with the Space Studies Board and the Aerospace Science and Engineering Board to produce the sort of topical and knowledge information bits that inform NASA and inform our government on what kind of science is important to the community. Today is the first semi-official reach out to the community to gather information. So we'd like you to do a couple of things. First thing is there's 3x5 cards on your chair, as Kevin mentioned. If you have questions now or through our talk or at the end that you want delivered to us and to the academies with regard to the process or scientific topics, please put that on the card. And if you have your mobile device or your laptop out, please bring up just what it says right there, slide.do, and input microgravity, because we're going to do some polling towards the end. Today is all about getting information from you guys into our collective wit.
Okay, so hi everyone, how you doing? Wake up! This is audience participation time. So we're going to run through these, but again, really exciting to be here, and we need your feedback. We need everyone 100% participation because we need all your great ideas. So great opportunity for our community to participate in the decadal surveys that, of course, under the Science Mission Directorate, the other science divisions have done for a long time, but we've done one. So think about the next decade. It's really critically important. Our input's critical, and a decade's a long time to plan for. Just can't imagine what we'll see in the next decade. So the characteristics then, is you're probably pretty familiar with. They're community driven, so this is definitely bottoms up. The aim is then to get the community census. What's the most compelling science? I might add science and technology. What are the most important critical things that we can do given this amazing chance to go back to the moon? So, what can we do in terms of life and biological and physical sciences? And we'll appoint a steering committee as NASA Decadals run. There'll be a steering committee, and we'll have topical panels so that, again, everyone can participate. And the surveys, this is a quick kind of in-person. Then we'll be looking for white papers, much more detailed input from the community in terms of white papers. And that'll be announced, soon, but in 2020, when we can really have you draft the white papers. So opportunity for everyone to participate. We're looking for volunteers. We're also looking for names and recommendations of people to serve, steering committee and panels and things like that. So it's going to be wide open to get as full of participation as we can. This is interesting in terms of looking at this decadal to also have some cost assessments and some technical evaluation of the proposed initiatives and the recommendations that end up in the decadal. So turn it over to Sandra.
So who asks for and who uses the survey? NASA actually asks for the survey and they utilize the survey, but there are a lot of users for decadal surveys. Congress uses the decadal survey quite extensively, and you'll often see that reflected in various congressional language that is for appropriations, for budgets, and guidance to NASA. And NASA, Congress has actually pushes very hard for the survey process to continue because it is an impartial source of guidance for them, an independent source of guidance for them on how NASA can best make use of its funding for science. The actual statement of task is negotiated between the National Academies and NASA. And as I mentioned, the sponsoring agencies and Congress view that statement of task and the results of the decadal survey as their guidance for what are the science priorities, where should they be spending money to get the most bang for their buck in the next 10 years. And this is why the decadal surveys are so important to the community. As Dava said, they are community driven, they're bottoms up, they are your voice, and we pull a lot of people into these studies, and we're really looking for your participation going forward.
Okay, if I may, prior to becoming the chief scientist, I was the head of planetary science for 12 years. And so indeed, when I came to NASA headquarters in 2006, we'd already had our first decadal and we were 3 or so years into it. So I used the decadal extensively in terms of justifying our program, developing a strategy to execute that program that involved international participation or connecting with the other divisions for joint activities that would then satisfy and go after those top questions that were done. I also, at the juncture about 2009, began the process of developing the task for the next decadal. And I can't emphasize enough how important that time period is, which is where we are today in getting ready for completing the task for the upcoming decadal in life sciences and physical sciences. What I did in that particular task was indeed provide input to the Academy to let them know about the great flexibility I needed within that program to manage. What I got back was a fabulous decadal that allowed me to indeed not execute the whole program. I liked the decadal because it had many more things in it than we could possibly execute. And the reason why that's important is that as we moved into that next decade, I was able to leverage and use that to create new starts and build the community in ways that were extremely important, and then and knowing that it was going to help support human exploration too. And so that decadal and how it was constructed was just critical in getting planetary to go from $1.2 billion when I started to $2.4 billion when I left last year. Okay, so that's a little context.
So our decadal, the decadal that you see on the screen there, came out in 2011. So you can see that 10 years from then is coming up, and that's why it's time to be spinning up this discussion on the decadal. For this particular decadal, it's just sort of important to remember that the one you see on the screen occurred at a very interesting time for our community. Those of you that are old enough remember the time as being one of a bit of chaos, and the decadal helped lay down a very nice work, a very nice foundation through which SLPSRA and the other parts of NASA that influence and fund our science, we're guided to what they do. If you guys haven't seen this, if you haven't looked at it, we're going to put up a website where you can find it. It's easily downloadable. It's a little bit big. Don't worry about it. Just remember chapters 1 and chapters 13. Okay? Those are the ones that really take an integrative approach in the very big body of science that our group, the group in this room, represents. And it's our job now to take that particular decadal and extend it into the second sort of phase, the second 10 years of its existence. This is a very special opportunity, and it's one that embodies everything that a decadal approach, a decadal survey is supposed to do, but it's built upon basically that original decadal that set our current state of being in place. The fundamental considerations are basically we need to take the long view. We need to be able to look, think, and innovate, ideate over a 10-year period. That's a tough task to do. All right? It is going to be likely to be a NASA-sponsored decadal. That doesn't mean that other agencies and other parts of the world don't have input to the decadal. So the decadal will consider, in addition to science priorities and platforms and technologies that we normally think about, it'll also look at interagency partnerships, international partners, and other things that go into the body of work that it's going to take to sort of move our science into the next 10 years. Some of the specific elements of the decadal charge are going to be typical of what you see in all decadals across the science that NASA sees. It'll include a review of the state of knowledge. It'll identify science priorities. It'll be especially important in the developing of Cis-Lunar commercial space to identify platforms and capabilities that are available and platform and capability requirements and how those overlap. In other words, the growth of the low Earth orbit ecosystem, how does that affect the science that can be done and the science that needs to be done? As most decadals do, it will be important to take a programmatic approach that enables basically a very big, very robust science program. What Jim Green was talking about in terms of the ability of that decadal in planetary to grow that area of science is certainly a goal of this decadal as well. And one of the things that this decadal will do that we haven't done in the past is to begin to take a look at costs, the costs of running missions and the costs of potentially grouping missions together in large campaigns. So what we'd like to do now is give you a very quick update on the current status of the next decadal, which will be coming out. Sandra, can I ask you to comment on this particular slide?
Sure, no problem. So right now we are in the process of finalizing what's called the statement of tasks. That's the charge to the committee. So we're having conversations with NASA, but we have a very mature draft in hand now. So we expect that that will happen in the near-term future. There are some institutional approvals and structural design work for the decadal itself that have to take place in the coming months. The earliest formal start for the survey, and I'm guessing a little bit here, but just based on past experience, is likely to be in the March-April timeframe. We could start earlier than that, but that's would be about the average from this point in time, with the final report due about 2 years later. And then, of course, this town hall is going to provide us with inputs for several of the steps in that process, particularly the design and early stages of the decadal. There are going to be some questions that we're going to be asking that will help the steering committee think, for example, about the potential panel structure for the decadal. We're going to be looking for nominations to serve. This is an early ask for nominations. There's going to be a later call, a more formal call that will go out to lots and lots of mailing lists asking for nominations, and there will be a pre-populated package. But if you're really anxious to send names now, there will be a place for you to send those names. And believe me, we are already starting to look.
And just to be 100% sure, it's okay to self-nominate. Yeah.
Absolutely.
If you are interested in being a part, please take one of the opportunities that will come your way, either electronically now as we do this pre-spin up data gathering, or later when the official things come out. There you can see probably the timeline that we're looking at overall. Again, these are all approximates, but basically the public report will be in calendar year 2022. So a couple of things to sort of point out about how this might be different than the original inaugural survey. That we are looking increasingly at systems. Those systems biology has come and is prominent now, but physical biological systems will be very important. It's likely also that we're going to be looking at campaigns that integrate over larger kinds of scientific endeavors. Twin study, for example, is a pretty interesting model to look at how we would propagate that into the future. And as I mentioned before, there are increased recognition and accommodation and wonderings about international partners, and especially non-NASA partners that are inhabiting the ecosystem of space science these days. You already saw on Jim's Artemis program, commercial people doing a lot of the stuff that is going on with regard to the science that is headed there. So here we are at the sort of the audience participation phase of our project today. We are starting the process of looking for community input, and you're invited to a survey that is at this nas.edu/microgravity website. If you go to that website, you will also see the members of the committee that are the members of the standing committee. You'll also see links to the decadal study that was done in 2011 and the midterm assessment of that decadal that was done a few years ago. You will also see a link to the request for input. And that's a place where you can raise your questions. You can start the process of wondering what's going to be included. You can put anything that you feel is appropriate as a query, in addition to answering the 4 questions that are there as a survey. So what we'd like to do right now is open the floor to questions and also to collect any cards where there are written questions. So if you have a written question, please pass them over to Gail. And if you would like to step up to the mic and verbally put a question, please do. So we have also Slido questions, but I don't have, do we have access to that now?
So they'll put them up. Want to go ahead and put up the Slido questions?
Okay.
Okay. Very good. So Fred, you're at the mic.
Well,
you can go first.
Yeah, I wrote it down, but I wasn't sure if it came up there. There's a revolution going on now in omics, of course. We talk about that a lot. But there's also a revolution going on in personalized medicine. And things are going to be happening over the next 4 or 5 years where there's going to be data collected by the NIH as well as another organizations on hundreds of thousands of people, and then be able to link the sort of, on a personal basis, your likelihood of getting various diseases, your health, and so on. So I'm just wondering how the Decadal Survey will it, or is it planning on taking into account and staying abreast with these major changes that are taking place in personalized medicine?
So I think the answer to that lies in the people that will be participating in the Decadal survey process. In other words, There will be scientists in there, hopefully, that do represent that area and the larger areas from other agencies. The decadal committees are not made up just of people in this room, but they're also made up of people from other parts of the community. So very likely and very intentionally, aspects of that will be captured. And again, the people that are in the room doing that are the ones that should be and likely will and always have reached out to those other communities.
I was thinking particularly in terms of astronaut health, but also the ground control people and how they're able to handle the stressful situations they're in. And it seems to me it's not just the astronauts, it's probably a much larger group of people who are involved in the mission. And right, if I'm on one of the committees, I'll bring this up at one of the committees. And so I just hope that will be part of the conversation.
Yep, thank you.
One of the functions of the white papers is really all about expressing those concerns, talking about the current status of the field, recognizing how the environment's going to change, and then being able to state clearly the kind of research that needs to be done to accommodate the new program as we move beyond low Earth orbit. So I would encourage everyone to write the associated white papers. Astrophysics is a little further along in their decadal, and they have about 800 white papers. So there's a significant input into that decadal that's currently being considered.
And rest assured, if we don't get to your question that was written online through Slido, we're collecting all those and we will be either able to answer them broadly or we will take them into account if we don't get to them today. So I'm going to take one at the very top. Are there minimum qualifications for contributing? In other words, can a young person contribute? This is an interesting thing. I'm going to nod over here to Sandra about that, because there is a balance between gathering broadly and having a big enough scientific footprint that the output is paid attention to.
So this isn't such an easy question to answer because we really need the ideas and the enthusiasm of the youngest cadre of investigators, because you are the investigators that will be taking over this program in the next 10 years. So you are the investigators that will be carrying out the recommendations that come out of this decadal. So of course we need your participation. And that participation can take place in a variety of ways, but I think probably one of the most important ways is going to be to contribute a white paper. That is where we really gather ideas from the broadest set of the community. Now, in terms of serving on the steering committee or the panels, I can't tell you exactly where the cutoff is in terms of experience, but as you might imagine, we are going to be looking particularly for the steering committee for people that have significant and broad experience. The panels, which will be more focused, will probably include younger members of the community. I won't say exactly how young, but the Academies does make it a goal to have good participation across the experience range of the scientific community. But just to return to the last point, it is important to remember that those of you that are at the outset of the career, you are the ones that are going to be carrying out the recommendations that come out of this decadal. So please, please do participate.
And I'd like to highlight, it's now the second one from Sid, life science is being done across NASA. And so good news there in terms of Slipstra kind of leading this, but we just had a meeting and absolutely, yes, input absolutely from space biology, HRP, astrobiology. So really all stakeholders were at the recent meeting to make sure that we're working across. And will everyone pay attention? We sure hope so. I mean, we have to get it right, but absolutely. So right now, all the stakeholders, we're getting really valuable insight and information, and trying to work across. SLIPS is leading it and organizing, but really connected and working across all the three, and then more that were even mentioned there. That's the way we can do the best job with NASA.
And one of the things I can add to that is The Space Studies Board does serve an integrating function across many, many decadals. And so there are definitely, even at the pre-policy side of things, ways in which the various decadals do interact with one another. It is interesting that in this particular case, and getting back to Fred Turek's question, the concepts of astronaut health are actually governed by a different survey, not necessarily this survey. So the basic science will definitely have to interact very closely with the documents that guide astronaut health. So I saw another question up there. How well did we do after the 2011 recommendations, and where can we look to see that? Again, I'll point you to the NAS microgravity webpage where the midterm assessment is left. That's about a 100-page document that does go over how well NASA dealt with the 2011 decadal. But the other thing I would just point out is that if you want to know whether or not NASA is paying attention to the decadal, just look at your grant proposal process. Your grant proposal process has to include a nod to the various parts of the decadal that guide your particular science. They watch it very closely. Did you see one you wanted to do?
I'm just trying to get the cards in as well. We can keep looking down. Love kicking the academies into the 21st century and having Slido in real time. Will it include decadal? So emphasize, I don't know the emphasis yet, but science of space, exobiology, science in space, more research in orbital, and science for space, life support. So right now, I think all those are on being discussed.
Yeah, I think all of those are on the table, particularly science in space and science for space.
The next question, written question, was whether or not the decadal will deal with lunar surface activities. And I think the answer has to be yes. This is absolutely a new door that is open to this group, and that, again, from our community's point of view, brings together the physical and biological things into a very close approximation to one another, and it's very much something that will have to be taken care of here.
Sandra, do you want to take one on Slido? I'm not sure if you can see this. There's a question about how to joint activities across Europe and America. So you can maybe mention that from the Academies representation of European folks as well, that red one.
I don't have a hard and fast answer for you, but the decadals always work to be cognizant of what is going on in the international programs. We usually have international participation so that we have a link to those activities. The recommendations, of course, are going to NASA. So we'll be looking at, what is NASA's role going to be, but understanding what is going on in the international programs will be very important because, as most of you know who are currently doing experiments on ISS, you're not doing this, it's not just a US vacuum. Many of you are working with international partners to fly your experiments. So this is going to be a key part of the discussion that's in the decadal.
As head of planetary, one of the things that I strove to do when we'd have bilaterals with a variety of other space agencies is to look over their program and then identify activities that they're doing that I could participate in representing NASA Planetary that would address decadal level questions. And that really guided me in terms of saying, these are the areas I want to work with you on, and that is the priority. And that has worked incredibly well. We've been really successful in linking with ESA and the Japanese Space Agency and the Indian Space Research Organization and others.
Yeah, okay. Yeah, that would be great.
Jordan, can we switch over to the real-time polling? There are a couple of questions that have come up, and again, we've captured all of these and we'll capture more, that deal with platforms. So what we thought we'd do is we'd switch over to some real-time polling. So please pull out your electronic pencils, go back to Slido, and work with us to answer this particular question. In the next 10 years, what kind of flight platforms would you prefer to use to conduct your science? Where do you want to work? Okay, one person answered.
Right. Yep, that's right.
Yeah, where do you want to do your work? This is interesting because NASA has to make decisions, and we all have to make decisions on where to put money for platforms and capabilities. It's going to be increasingly important as our ecosystem develops that we understand where you want to do your work. Now, after we capture this information, we're going to change the context, change the text within the question just a little bit. And you can continue to answer these questions once we move past these. Isn't that right, Jordan? No?
Has to be now.
Has to be now?
That's what she said.
Okay, so we're just gonna watch this a little bit more, but pretty soon we're gonna cut it off in order to move to the next question. If you didn't get a chance to answer this one, it's just because you're slow. So please be faster on the next one. But these are already really interesting data, right? These begin this is a real-time sampling of what you are thinking about right now. So I'm gonna give it another 30 seconds. And Jordan, go ahead and switch over to the next question. So we're going to switch now from where would you like to work to where do you actually think you're going to end up? All right. So this gets to sort of a nuance between where would you really like to do, but what do you really think the outcome is going to look like for you and your science? It'll be interesting when we finish to ask whether or not that distribution looks the same, or whether there are big places where there might be investments that could be cool for NASA and the community to think about. Now people are moving faster now. The gauges aren't changing quite so quickly.
82. What's it?
Yeah.
So the number of participation is up in the upper right
Exactly.
corner.
Yeah.
90.
I'm so open. That's great.
Good.
Capturing 100 or so votes.
We're pretty close to finishing up that one. Now, when we get a little bit farther down here, we're going to switch to some other kinds of questions. We're not only just collecting data today based on what your responses are, but we're also priming you for ideas for things to write in your white paper and in your response to the survey that you'll find at that National Academy site. So there are 4 really important questions at the National Academy site that draw on the things that we're doing today. So please do go there and continue what we're doing right now in the full survey that is there. Jordan, go ahead and pull up the next one. This gets to a different part of the kind of things that we're interested in worrying about as we consider the decadal. Where do you see your funding coming from over the next decade? And you can see this one is technically different than the other ones in that you can only choose one answer. So, we're really trying to get to where you think your science is going to be funded from. And again, people are getting quick, but they're also only having to choose one thing. So very good. Jordan, let's go to the next one. A slightly different version of that same question. Do you see opportunities for your funding for work outside of NASA? So as you watch those graphs move, I think we can basically conclude our statements for today saying that we really appreciate the time to be here. We appreciate the questions that we've gotten, The ones that we have written here and the ones that we're capturing from the online form are good. They are the kinds of things we needed to get a hold of. And
We had time.
yeah.
Okay.
And the important thing is that the process is started and we really need you to be continued engaging. If you notice from that timeline, by the next time we meet as a society, the writing will be occurring here. So this is the time for this group to realize it's time to have an input. Start with that survey that you can find at the academies. Follow through when it comes time to participate in submitting white papers. Last year we had about, or last decade, we had about 170 white papers. 2 pages, 3 pages, 1 page, 10 page, doesn't matter. Get your stuff in there. These things are read and paid attention to. Anything else from the group?
So just to mention that the call for white papers will come out later, but you saw on the screen earlier the Academies website, and I don't know if it's possible to get that slide back up on the screen with the web address for the survey.
There you go.
There you go. So that last address there, there's additional information on that site, and there's a link asking you to provide your initial input to the survey to those 4 questions. So please take a look at that. That's going to be open for probably the next few months while we get things geared up. So we will be looking at your responses there.
Thanks, everyone. Slido's still open. It's great to see a lot of these questions come in. So we are, archiving them. Sorry, we can't answer more of them today, but just to start the discussion, this is what this is. Exciting opportunity to start the discussion. So please keep Slido still open. Get to the National Academies page, and we look forward to working with you all.
Well, I'd like to thank the panel for that very informative meeting. And remember, even though they're going to do a call for white papers, you can begin to talk with your colleagues and others to begin to formulate what those white papers are going to be, and so that you're ready to go when the call is out there. So again, I'd like to thank the panel for this great opportunity to see and get some insight into the Decadal Survey. Thank you.